Hello students, Miss Slyman here with our first set of notes for Unit 2. So hopefully in that 2.0 investigation exploration, if you finished it, you determined rules for the exponents. If you didn't finish it, maybe you already know the rules for the exponents, and if not, I'm about to tell you the rules for the exponents, but for sure doing this exploration will help you to have a better idea. So like I said, we're starting Unit 2, this is algebra. A lot of this IB topic is really in the prior learning part of our syllabus. This part today corresponds to textbook 3A. So let's go for this first part is just the exponent rules. So we've got our first style of problem, which is when we multiply numbers that have the same base. And hopefully what you found is that we leave the base alone and add the exponents. So that looks something like this. Same base, my base here is A. So let's just make a note here that A is the base. And so it stayed the same and we added the exponents. So now let's look at this rule. So this rule is, I look like I have a quotient, so a divisor. They have the same base, and the rule looks to be that I subtract the exponents. So let's go on and fill that in. So if we divide numbers with the same base, then we, much like above, leave the base alone. And this time we subtract the exponents. All right, so let's look at this next one. In this next one, let me come back to here. Hopefully we can make that bigger. Oh. All right, in this next one, we raise a power to a power. So I imagine that's going to look something like a power raised to a power. And hopefully in your exploration, what you discovered is that in that case, we leave the base the same again, and we multiply the powers. So I'm going to leave that for you to fill in here. All right, directions here. Separate the product. So I'm thinking in my head that's a multiplication into its separate factors and apply the exponent to all factors individually. So we've got some sort of product, so let's go with A times B, and it's got an exponent, and I'm going to separate those and apply the exponent individually. It still ends up being a product. Maybe you want to add that to your notes here. So over here, it looks like what I have happening is a product raised to an exponent. I've got the counterexample down here. I've got a quotient raised to an exponent. And here it looks like I separate the quotient and apply the power to each part of the quotient, the dividend and the divisor. All right, so I'm going to leave that for you to fill in. Raising a non-zero base to the power of 0. So A to the power of 0, I'm going to make over here a note, A is not 0. Non-zero base to the power of 0, I really, really, really hope you learned that that is always 1. And now a negative exponent implies division. So we can rewrite a negative exponent as positive if we move it to the denominator. So if I have A raised to a negative exponent, I can make that negative exponent positive if I put it into the denominator. Well, I can't just leave a blank numerator, so I'm going to put a 1 up there, unless there was something else that I was multiplying by. In this case, there's an imaginary 1 in front, really, so I'm going to put that up top. So this is a base raised to a negative exponent. I have sort of the opposite over here. I have 1 over a negative exponent, and it comes up and becomes positive. So now I have 1 over, I don't know why I wrote the 1 over, this needs to be words. I'm going to type it so I have some more space. So we have 1 over a base with a negative exponent. Well, again, negative exponent implies division. So this means I have a number divided by a fraction. Yeah, so if you have a number divided by a fraction, it actually gets bigger. So let's look at some examples of this. So if I have, for example, 5 divided by 1/2, then I get 10. So it's actually like multiplication. So that would be the same as 5 divided by 2 raised to the -1. So I've got a negative exponent, but I could bring it up and make it positive, and I get the same thing. I get a positive 10. So 1 over a base with a negative exponent would be the general type of problem here. And what I can do then is, let's try and make this bigger. All right, 1 over a base with a negative exponent. Well, because we're dividing by a fraction, it actually turns into multiplication. So it comes out of the denominator into a numerator, and I really have like an imaginary 1 down in the bottom here, and I make it positive. So I'm going to leave that for you to fill in, and those are the exponent rules. I'm going to come back with another video to look at examples.